But we're going to be looking at some bell work first. So a variable is just a letter, a symbol that we're solving for. So it can represent various amounts of numbers, certain quantities. It just depends on what we end up solving for. And then we have an expression and an equation. An expression and an equation are both mathematical statements. It's just that one has an equal sign and the other one doesn't. On your multiple choice quiz, which I'm going to give you on Thursday, you'll be able to know your score right away because I'm going to be giving quizzes on Illuminate. So you'll drop it in a little box. It'll tell you your score. And I'm going to be looking at, you'll get 2 scores. You'll get a score for the right answers. And then I'm going to look at the ones that I said show work for. And then I'll give you a score for your work as well. So just be aware that that's how the quizzes are going to go in this class. And that will be on Thursday with the review game tomorrow. So expressions do not have equal signs. Equations do have equal signs. Questions on that? Does anyone need more time? All right, good. I'm recording here. So simplifying is just getting an equation or a fraction into its simplest form, or an expression down to its simplest form. That means if you can use order of operations, use order of operations. If you can simplify your fractions by reducing them, then reduce your fractions. You need to assume that when you're solving equations, I want you to simplify all of your answers, and that in particular includes those fractions. So if you have x equals 6/12, you're going to have to simplify that and give me x equals 1/2 as your final answer. You may have seen the word evaluate before, and you'll see it a lot more in this course. And that just basically means to substitute a given number for a variable. So I may say evaluate the equation x plus 4 equals 2 for 5, x equals 5. So all that means is you're going to plug in 5 for x, and then tell me what your output is, what you get whenever you plug in 5 for x. Does anyone have any questions so far? Anyone need more time? Okay. Okay, so in this section, we're going to be looking at multi-step equations 1.2 on page 12 in your textbook. The difference between what we're doing today and what we did last class is that we're just adding a little bit of complexity to the equations that we're solving by just applying more than one step to isolate the variable. Isolate meaning what? What does isolate mean? Yes. Yeah, to get it by itself. If you're isolated on an island, for example, you're by yourself on an island. So, essentially, like I said, it's just what we did last class. We're just adding a few more steps to it and coming to the same conclusion. Still using those properties of algebra, still using subtraction property of equality, and addition property of equality, etc. Just, it's going to take a little bit longer. So what's the first thing that I do for that equation on the first page? Yeah, I add 13 on both sides. Now, some people were having trouble last class with just understanding this concept for some reason, and the way I think about it is you want to isolate your variable from the outside in. So you want to get rid of everything on the outside first before you work your way inward. So I'm going to get rid of that 13 because that's the outermost thing that I have to get rid of. So I'm going to add 13 to both sides by using that addition property of equality. Of course, you can rewrite that 13 so it lines up better with the 2. And then those 13s cancel out, and you get 2.5x equals 15. So, again, I'm working from the outside in. Now I have a 2.5 I have to get rid of, so what do? Divide. So I'm going to divide by 2.5 and divide by 2.5. Well, these cancel out because they're inverse operations, multiplication and division. And then I have a 15 divided by 2.5. You can plug that in your calculator. You're more than welcome to use calculators because I'm assessing solving equations, not basic operations. And 15 divided by 2.5 is what? 6. Yes? Yes, so I'm doing this problem right here. Yep. I just rewrote it. So I get x equals 6. If I wanted to get rid of that decimal, I could multiply the numerator and denominator by 10, and that would be 150 over 25, and that's also 6. And then, like a good student, I'm going to circle my answer. And then I can check my answer as well. Don't underestimate the power of checking your solution by plugging it in. So I'm going to take 2.5, I'm going to plug that in, and see if I get a true statement. And what I mean by that is if I get 2 equals 2, then I did it correctly. 2.5 times 6 is going to give me 15. Does that equal 2? Yes, it does. 2 does equal 2. Checked it. It works. It's a solution, and you can move on with your life knowing that you got this correct. Questions on how I solved this multi-step equation? Questions? Okay. Anyone need more time? Okay, a little more time. So on this top equation, what's the first thing that I do? Okay, so never mind. So let me go back to what we were doing. We're adding 11, and we get negative 10 equals 1/2 c. So we talked about on the first day that we have an inverse property for multiplication and addition. For multiplication, when we multiply two inverses, what do we get out? What number? 1 or 0? 1. Right. So for example, if I have negative 3, its additive inverse is positive 3. When I add them, I get 0. When I'm looking at multiplication, if I take a 1/2 and I multiply it by 2 over 1, then I get a 1, right? And we want a 1 because we just want a 1 in front of the c. 1c and c are the same thing, right? So I'm going to multiply both sides by 2. That's the same thing as dividing by 1/2 because you flip and multiply. Well, the 2 over 2 cancels out, and I just get a 1. And then a 2 times a negative 10 is going to give me a negative 20. So in the end, I have a negative 20 equals c. Does that make sense? And then I can flip that around so it's read correctly. C equals negative 20. Do you have questions about solving that? Yes.
Doesn't it make a difference by just switching it around, like the variable goes first and then the answer, or is it?
So it doesn't technically make a difference, but it's a matter of notation. So in mathematics, we read everything from left to right, right? So think about it in an English class, you read a book from left to right. In mathematics, we establish the same rules. So when I'm reading an answer, I want to read from left to right, meaning that I want the variable that I solved for on the left. Questions on that? Now you will have a problem on your worksheet that's something like this. P plus 2 over 4 equals 2. And a lot of people were struggling with that. What can I do to make this problem easier for me? Do you know? Yes?
Could you add the 1 and 2?
So you don't want to add the 4 and the 2 because are adding and division inverses?
No.
Well, they undo each other. No, they're not inverse operations. So what do you think I should do? Yes?
Multiply 4?
Yeah. So in one situation, I had this where I wanted to add the 11 first and then get rid of the fraction. In this situation, when the whole thing is a fraction, get rid of that fraction. And to get rid of that fraction, multiply both sides by 4. So those cancel out because you got a 4 on the top and the bottom. And then so you end up with p plus 2 equals 8. Then subtract 2 and subtract 2, and you get p equals 6 in this case. Does that make sense? Okay. Questions? No? All right. All right, so what's the first step on the first equation? Someone else. Combine like terms. Right, I have like terms. I'm going to combine them. These two both have an x, so I'm going to combine them. A negative 2 minus a 10 is going to give me a negative 12. X plus a positive 12 equals 18. Well, now, what am I going to do? Yeah, subtract the 12, get rid of everything on the outermost of that variable, and I get negative 12x equals 6. What's the next step? Divide by negative 12. Divide by negative 12. Now I'm running out of room, so I'm going to go to the corner here. Just draw an arrow. And I'm going to write it in blue. So these negative 12s cancel out. I get x equals, what's 6 divided by negative 12? What's that reduced to? Yeah, negative 1/2, negative 0.5. Remember, if I just have the negative on the bottom or just the negative on the top, it's the same thing. Just the fraction's negative, right? The only thing I can't have is a negative on the bottom and the top. And most often, we just write the negative outside and just put negative 1/2. Questions on that? Of course, you can plug it in and see if you did in fact do this right. Negative 12 times 1/2 is 6, plus 12 is in fact 18. So I did that right. Now you will have a quiz question on Thursday, just like the one that follows. It's going to be worded a little bit differently, but it's going to ask the same thing essentially. It says, are the following equivalent equations? What do you think? Why or why not? So I'm talking about these bottom two. Are they equivalent? Yes. They are. Right. Well, one way is to solve them both and you'll get the same thing. But what I really did is I showed you two types of equations that are equivalent but of different forms. Meaning that I could make both of these look like the other one if I just multiplied both sides by the same number. How could I make this look like x plus 8 equals 12? Yes. Yeah, multiply both sides by 2, exactly. If I multiply both sides by 2, I'm taking 2 and I'm multiplying it by the entire thing. A common error is that people will not take the 2 and multiply it by everything on one side. They'll just multiply it by one thing on one side. And you don't want to do that. You want to take the 2 and distribute it to each of the terms. 2 times 0.5 is 1, or just 1x. 2 times 4 is 8. And then 6 times 2 is 12. So this turned out to be this. And it's fine because our algebra properties say we can always change the form of our equations if I multiply both sides by the same number, or add the same number to both sides, or subtract the same number to both sides. Does that make sense? Why is this important? Well, sometimes you'll be solving equations that have fractions in them or decimals, and you don't want to deal with fractions or decimals. You want to make it easier for you to solve. So you might want to consider changing the form by multiplying both sides by a number. Does that make sense? All right. So what property will I have to use here? Distributive, right, I heard it. 2 times 1 and 2 times x. 2 minus 2x plus 3 equals negative 8. And then I can combine my like terms, just like I've been doing. Negative 2x plus 5 equals negative 8. And then, what? Subtract 5. So I'm just going line by line here. Negative 2x equals negative 13. And then divide by negative 2. That cancels out. So x equals 13 halves. What's another way to write 13 halves? (6.5). 6 and 1/2 is a mixed number. 6 and 1/2 is a mixed number. 13 halves is an improper fraction. So just as a refresher to get your improper fractions as mixed numbers, you ask yourself, how many times does 2 go into 13? It goes in there 6 times with 1 left over. And then you always put the denominator on the denominator there. All right, so for the summary, I just want you to give it a try. We'll go over the summary after the quiz because tomorrow's going to be a review on 1.1 and 1.2. Does anybody have any questions so far?